Hi, welcome to the Chico Math Lab. And this is the AP Calculus lecture number 3. We are still working on the limits. Okay, in the lecture number 2, we stop at, how about when you try to find the limit, you have the 0 over 0 situations here. Okay, so that's why it's a division by 0. So we have 0 over 0, or you have some divisions like a minus, the divisions here. So here's some constants here. All right. So the lecture number 2 we deal with is how about if you have 0 over 0. And so the first methods here we talk about in the lecture number 2 is we'll try to factor. Okay, so if you can factor both numerator and the denominator, and then we see we'll be able to cancel out some trouble terms. We stop at, we finished this one, how to factor, and we did several problems. So for this lecture, so we're going to talk about a few more technique we can use. So the first one's here. So how about the fractions here? We have 0 over 0 situations, right? So the fractions involve with square roots, the roots function, or we call this the square root functions here. And it's not easy to see how can we, the factors here. So the one of the techniques we're going to use is we talk about is multiply the conjugate. Okay, then the other situations here, we have like fractions minus fractions with the division by 0. Right, like the one we talk about here is like some C star over the 0 minus some other C star minus the 0. So for this type of the situation, what do we do here? So in here, this one, the most common way to deal with this situation is we use algebra to combine the fractions. So basically, we need to use our algebra skill to combine the fraction by applying common denominator. Right? So after you combined, then you can see after you combined, will you be able to factor and cancel some common term? Or maybe you need to do one next step is multiply the conjugate if it's involved with the square roots here. Okay, so let's take a look. These two skills we're going to learn today is how about the fraction involved, the square roots, how we do that. Okay, and how do we combine the fractions here? So let's go ahead and go to our worksheets and take a look at some problems here. All right. All right, so at the lecture number 2, we did it by factoring method and we stop at the problem number 8. Now today, let's continue. Go ahead to start the problem number 9 here. So evaluate the limit. If limit is not exist, let's say it's the BNEs here. All right, so let's take a look at problem number the first part, but h equal to 0. So first things you say h equal to 0 here, right? So then this one go to 0. And h equal to 0, 0 minus 3 the square, so it's 9 minus 9. So this is equal to 0 here, okay? So for this one, so we say, okay, it's 0 over 0. So this one's here, we use this problem kind of the refresh what we did in the lecture number 2. So in here you say, oh, okay, here maybe I can do is, depends, right? There are several different methods. You can say I can factor it because this is a square minus b square, right? So you can treat it as this is a square minus b square. So b is 3 and a is h minus 3. So remember we said this is probably is one of the most important factor formula in the calculus here. So the a squared minus b squared is a minus b times a plus b. So you can say it's h minus 3 minus 3, then times h minus 3 plus 3. Okay, so now in here you will see, okay, 3 and 3 cancels, right? So what do you have here? So you have a limit h approach to 0. So this is h minus 6 then times h. So now because you factor, then the h and the h is cancelled. So we can have here is limit h approach to 0 and h minus 6. So that means this number approach to 0. So what is the final answer? The final answer would be negative 6. That's right. All right. So now let's take a look at the next ones here. Okay. So this one, so limit h approaching to 0 again. So this approaching to 0. Then the top one approaching to square root of the 9 minus 3. So I know the square root of the 9 is 3. So this approach to 0. So this is another 0 over 0 situation. All right, so now this is the functions involved with the root function. So we said, okay, if it's involved with the root function, maybe let's do the conjugate ideas here. So what do I mean the conjugate? So it's h approaching to 0. So this is h. This is 9 plus h minus 3. So the conjugate, that means if original is minus, you change it to the plus. All right, so that means I need to multiply this one here is 9 plus h. So the conjugate here, what I change it to the plus 3 here, okay? And so the denominator, you do exactly the same thing. So it's 9 plus h plus 3, right? So basically, what you did here is, so basically that means in here, you basically just multiply by 1, right? So that's good because I cannot just multiply a functions by any other number by 1 is fine. Okay, so that's why when we talk about the conjugate, you multiply the numerator and the denominator by the same things. Now the next step here will be, so the next step here will be you multiply the numerator and you multiply the denominator. So this is a lot of students got confused. They said, oh, the conjugate, so they just do the plus 3 and they forgot you need to divide by exactly the same number. Then afterward, then you multiply the top. So the top here is 9 plus h minus 3, 9 plus h plus 3. So this is become the a minus b times a plus b again, right? So this is a squared minus b squared. So my numerator will be a squared will be 9 plus h minus b squared will be 9. Okay, then the bottom, just leave what it is. So it's h times 9 plus h, right? And then plus 3 here. Okay, so now here, this is the limit, h approaching to 0. Then you have an h here, and this is h. Then this is 9 plus h plus 3. Take a look at what happens. What happened here? Okay, so h and h cancel. That's pretty nice. So I will have a limit h approaching to 0. Then this is 9 plus h plus 3. right? So now when the h getting closer and closer to 0, then this number, this equation going to approaching to what? Square root of 9 plus 3. So it will be 1 over 6 here. Okay? So that's what we mean. We can, do the conjugates here. So let's try to do one more conjugate. So the part C, this is pretty easy, and you can practice by yourself to see you'll be able to get it or not. All right, let's take a look. All right, so the H is here. So I have 16s here. First, always check, do you get do you get a 0 over 0 now? So this is a 4 minus the square root of the 16. So the top is 0. Then the bottom here is 16 times the 16 minus the 16, the square. So it will be 0. So I know this is 0 over 0 situations here, right? Okay, so now let's see, of course, like I said, let's have a different method we can do. In here, let's see here, if I want to, the times the conjugate here, all right? So here, let's see here, this is limit x approach to 16. So this is a 4 minus the square root of x, 16x minus x squared. So remember, we conjugate is we times the opposite signs, right? So this is a 4 minus the square root of x. So I'm going to do 4 plus the square root of the x. So the denominator is exactly the same. It's 4 plus, right? Just like the one we did before here, right? So it's a 4 plus. And then you times the denominator and you times the numerator. Okay, so now here, after you times the denominator, so this is 16. So the numerator will be what? The a minus b times a plus b. So it's a squared. So it's 16 minus b squared. It's the square root of x squared. So it's 16 minus 6. And then you have 16x minus x squares here. And then you just times 4 plus. Don't try to simplify it. Just do like this, right? Then here you see I have an x here, I have x here. So I can, the factor x out from the denominator. So my numerator still is 16 minus x. So the denominator, if I take the x out, so what I have here, so it's 16 minus x, right? And this is a 4 plus. All right, so 4 plus the square root of x. All right, so now you see the good things here. So here and here, I can cancel, right? So what is this one become to? So this will become to limit x approach to 16. So this is 1 over x 4 plus square root of x. So when the x approaching to 16, this one will approaching to 16 times 4 plus square roots of the 16. Right, so square root of the 16 is 8, is 4, right? So 4 plus 4, so it's 16 times 8 here, right? So let's see here, what is the 16 times 8? So it's 128. So the answer here is 128. So this one is just we did a little bit extra. It's like after you times the conjugate, then you look at your denominator, you say, oh yeah, here I can factor the x note. Okay, so now let's take a look. Some other problems here is the one we said we have fractions. All right, so now let's take a look. Okay, so this one's here. Okay, let's check. So x minus 3, so 3 minus 3, this is 0. And x equal to 3, so this is 1 over 3 minus 1 over 3. Arbitron, this is 0 also, right? So I have a 0 over 0. Now I have a fraction. So remember, like In the beginning, we said if we have a fraction, so typical, what do? We want to combine the fraction to simplify it. Okay, so let's take a look. How do we combine it? So this is x approaching to 3. So this is x minus 3. So the top is 1 over x minus 1 over 3. So what is the common denominator? It's 3 times x, correct? So this is 3 times x minus 3 times x. This is my common denominator. So the first terms here is 3. The here is 3 minus x. So this is limit x approaching to 3. So this is x minus 3. Then I have 3x, 3 minus x. Then, we use the fractions. If you have a complicated fractions here, what do? You treat this as x minus 3. You flip, right? You multiply, you flip. So it's all algebra. So this is 3 minus x, 3x. You flip, this is x minus 3, this is 1. Then you see a good sense. This is 3 minus x. This is x minus 3. So they are only different by a negative sign. So what can you do? You say, hey, maybe we can try this. I put the negative out here. So then this term becomes x minus 3 times 1 over x minus 3 here. Then you will see this one is cancel. So your answer will be limit x approaching to 3. Then this is negative 1, 3x. So what is the final answer? Negative 1, 9, right? So when you see a fraction, most likely you will do is try to combine it. All right, let's take a look at part G's here. So for this ones here, we have 1 over t and 1 over t square, 1 over t square plus t. So this one is when t approaching to 0. So it's, and this one is approaching to 0. So this is like the infinity minus infinity situation. So what do we need to do? Like we said before, what do? We will try to combine it, right? Use my algebra, try to find the common denominator and combine it. All right, so let's take a look at t approaching to 0. So what is the common denominator? So if we here, this one, if you simplify it a little bit, so if you take a t out, so this is a t plus 1, right? So I know the common denominator will be just what? T to the t plus 1 minus this one's t to the t plus 1. So the first things here, you see the denominator for this fraction. So you can factor that out. Okay, so if the first one's here, the common denominator is t to t plus 1. What is the numerator? Will be t plus 1. Right? Okay, so now you can combine it. So this is a t approaching to 0 and the t plus 1. All right, so this is a t plus 1 minus 1. So this will be limit t approaching to 0. Now here, 1 and the negative 1. 1 and the negative 1 cancel. So you will have a t and the t plus 1. Wow, this is pretty neat, all right? So t and the t cancel. So you have so this one here is the limit t approaching to 0, 1 over t plus 1. So what is the answer? It's 1, right? So because when this is approaching to 0, so the whole fraction is 1. All right, so let's try to do a combination once here, all right? So let's try to take a look at problem I. So this one's here have the root function, have a fractions here. So like we check here, so this will be 1 over 0 minus 1 over 0. So it's infinity minus infinity situation again. So now we say, okay, what do we need to do? Combine the fractions here. So this one, let's see here, how do we combine the fraction? So the common denominator, this is t times the square root of 1 plus t. And so this is Okay, so other one is just 1 over t, right? So this is a t times the 1 plus t minus this is a t, the 1 plus t square roots. So this one, nothing changes, 1. So what happened to here? I need to times 1 plus t, right? Because of the common denominator. Okay, so now I have a common denominator. So this will be limit t approaching to 0. So I have a t square root 1 plus t, and this is 1 minus square root 1 plus t. Wow, if you put a t equal there, there's nothing you can cancel. You still, if you put a t approaching to 0, you still get a 0 over 0, right? So we still have troubles there. So what we can do, then you see here, you say, okay, after I find the common denominator, I end up with this root function. So we say, so what I can do, I can times the conjugate, right? So because this is 1 minus, so my conjugate will be 1 plus, right? So remember, the conjugate is the opposite sign. You have a minus, you put a plus here. So this one is 1 plus square root of the 1 plus t, just like we did the other problems here. Now, you times the numerator and you times the denominator to see you be able to cancel some number or not. So this is a limit t approaching to 0. So remember this a minus b times a plus b. So it's a square minus b squared. So it's 1 minus 1 plus t. All right, so here this is my denominator. So it's a t 1 plus t times the 1 plus the square roots of 1 plus t, right? Like I said, we don't want to simplify the denominator. We don't want to distribute it. I just leave like that. So this will be limit t approaching to 0. So it's 1 minus 1 minus t here. Then this is t is 1 plus t, and this is 1 plus 1 plus t. Okay, so now you'll be able to t and t cancels, right? All right, so t and t cancel, then this limit will be limit t approaching to 0. This is 1 plus t times the 1 plus t root, right? So here, this approaching to 0, this is approaching to 0. All right, so the whole thing will be approaching to, so the whole square root, this one is approaching to 1 times 1 plus 1. So the answer is 1/2. Okay, so this problem, and in this class, in this lecture, we did a 1, 2, 3, 4, 5, 6, 7. We did a lot. So the remaining, few problems, 3 problems, you can treat as the homework and try to practice to see you'll be able to, get the answer or not. All right, so now let's take a look at another technique we're going to learn. How about the involved absolute value here? Okay, so now let's go back to our lecture notes here. All right. Okay, so now let's back here. So we covered, the multiplied conjugate and algebra and try to combine the fraction. How about, you have a 0 over 0 situation, the involved limit involves absolute value. Okay, so if limits involve the absolute value, one of the very, very basic algebra skill we need to know is the ones here, what do we need to do? We need to break the absolute value. Okay, so we need to break the absolute value sign. So how to break? In our algebra, if you don't remember, so we say the absolute value of the x. you can break through the absolute value sign, let the x come out, right? So we say break the absolute value and let the x outside, let the x out the absolute values, right? So how do I break it? So the way I break it, so in the algebra, we said that this one's here, we can have two way. So it will be equal to x if the x is greater than equal to 0, or it can be negative x if x is less than 0, right? So this is a super important algebra skill. If you don't remember, you need to go to refresh your algebra. So this is how do we break out the absolute value if the limits involved 0 zeros later. All right, so let's go back to our worksheets and take a look at some of the problems here. Okay. All right, let's take a look what happens here. All right, so here, the first problem is here, they say limit x approaching to -4. All right, so this one does not involve the 0 over 0, so we can just directly use the substitution methods, right? So when the x approaching to -4 here, so what is this number going to approaching to? So that means this number going to approaching to zeros, right? So because the -4 plus 4 is very close to 0, so after you get out, so this absolute value will be able to very close to 0. So this number will, so the whole thing's limit will be equal to 0 minus 2 times when the x approaching to -4. So this will be what? This will be 8. Okay, so now let's take a look the second ones here. Okay, so the second ones here, so when limit x approach to 0.5, be careful here, let's say it's from the left-hand side here. Okay, so let's see, let's check. So when x approaching to the 0.5, 1/2, so top is going to getting very close to 0. So the bottoms here will be 2 times the 1/2 to the third minus 1/2 to the squares, right? So the bottom will be very close to 0. So this is what happens here, right? So it's 0 over 0 situation. So now in order to get the limit, I need to break the absolute values here. Okay, so let's take a look. So this is the limit x approaching to 0.5 from the left-hand side. Okay, so the top does not have a limit, that does not have the absolute value. So we put a 2x minus 1 here. All right, so the bottom, okay, so the bottom here, you see here, oh, maybe I can do a little bit of factoring here. So take a look here. So this is, I can factor the x squared out. Then this is 2x minus 1, right? The whole thing still is inside the absolute value. And now I can take the x squared outside the absolute value. Why? Because when you take the x squared, doesn't matter, it's always positive. So you break the absolute value already. So x squared can come out without any problem. So the inside we still have 2x minus 1. See? All right. Okay, so now let's take a look here. Okay, let's continue here. So x approaching to 0.5 from the left-hand side. So from the left-hand side, this is a 0.5 or 1/2. From the left-hand side, that means I'm approaching from here, right? So the left-hand side, so it's always a little bit less than half, right? Always a little bit less than half. Okay, so see what happened here. This is 2x minus 1. So this is x squared. So because the x is from the left-hand side of 0.5, is always a little bit less than half. So the whole thing's inside the absolute value is going to be what? It's less than 0. Correct? We just do that. Okay, so now because the absolute value is less than 0, so in order to break the absolute value, I need to put a what? I need to put a negative sign here, right? So negative x, right? So here the x is 2x minus 1. Right? Remember from the lecture notes, we said we need to, if the inside absolute value is negative, we need to break it. How do we break it? We put a negative sign in front. Okay, so now after you break it, then here, this one, you can cancel. Okay, so after you cancel, you still have, don't forget, you still have this negative signs, right? So now when x approaching to 5, so what is your answer? So I put a negative signs here. So this is 1/2 to the squares, right? So I'm going to the limit going to approach into negative 4th here. Okay, now, okay, let's take a look at the part C here. X approaching to negative 4. Okay, so for this ones here, the absolute value, the top approaching to 0 and the bottom approaching to 0 as well. Okay, so this is the absolute value. You know, the both have the denominator and numerator approaching to 0. So let's take a look at how do we break it. Okay, so in order to do how do we break it? So first things here, I said a negative 4. Let's try to approach this from the left-hand side. Okay, so if you try to approach it from the left-hand side, so if it's here, this is the negative 4, right? If you approach it from the left-hand side, so what happened to the x plus 4? So x plus 4 will always be less than 0, right? So if you say negative 5, so this is always be less than 0. So because it's less than 0, how do you break it? You put a negative sign. So it's x plus 4. Right, remember that, how to break the absolute value? And then the buttons here, I can just factor the 2 out, is x plus 4. Then you see, oh, okay, x plus 4, x plus 4. You cancel that out. So what happened to here? This is negative 1/2. Okay, and now let's see here. How about if I say limit approaching to negative 4? Okay, so now let's see here from the right-hand side. Okay, so if I'm approaching to from the right-hand side, that means it's always a little bit bigger than negative 4. So x plus 4, you can think about the negative 3's, right? So this would be greater than 0. So if it's greater than 0, what I can do, I can just break it out from the absolute value directly. So it's x plus 4. So the bottom still is to the x plus 4. And then the x plus 4, you know, the x plus 4, you can cancel out. And so the limit is 1/2. Ah, you find out the right limit. So this is the right limit and left limit. Right? So this is the pink one's right limit. So the right limit and the left limit, they are not equal. So what's that mean? That means the limit, this limit is what? Do not exist. Right, so this is how do we break it. So the reason why we did not do the part B is because the part B only want us to do from the one side here. Okay. All right, so now let's take a look at one more, and I leave the 2 problems for you to practice here. Okay, so let's take a look at this one. So this is the x. Okay, so this one's here, they said that x is from the left-hand side. Okay, so now let's take a look here. So if you put a 0, so this become 1/0, 1/0 situations, right? Okay, so now we know we need to combine. All right, so we need to combine the fractions. So it's kind of we learned from the previous skill. Okay, so now here you see here, this is the limit x approaching to 0 from the left-hand side. So what is the common denominator here? Will be x absolute value x minus All right, so this is x absolute value x here. So this one here will give you absolute value x, and this is x, right? Okay, so now let's see here. So this is x approaching to infinity, now negative from the right hand side. So combined, so it's the absolute value of x minus x. Okay, so here, okay, now let's take a look here. You know, in here, okay, so this is zeros, right? So when the x approaching from the left-hand side, so I know that x is less than 0. So in order to break that out, what I need to do, I need to what? So this is limit x approaching to 0 from the left-hand side, right? So I need to put a negative x in front of this absolute value, right? So this is the one. So this is the one I break out from here. Okay. Very good. So the top will be the, okay, so then the bottoms here, so will be x times negative x here, right? So these ones here will be limit x approaching to 0 from the left-hand side. So this is a negative 2x, and this is a negative x to the square. Okay, now let's see here. So negative, negative, this one become positive, right? Then the x here, I cancel x, so it's 2x. Okay, so this is 2 over x when x approaching to 0 from the left-hand side. So what is this number approaching to? This number approaching to the negative infinity. That's right. So during our first lecture, we talk about how do we find the vertical asymptote. That's why this one approaching to the negative infinities here. Okay. All right. So that's the, so that's what we have here, and this one. So for the part D, this one's here, I think you should be able to do it when, as your homework. So this one's here, because they just tell us approaching to -2. So you're approaching to -2 from the left-hand side, then you're approaching to -2 from the right-hand side. Then to see, you'll be able to cancel or to see the limit will be the same or not. All right, that's it. And so let's stop here. And so looking forward to talk to you next time when we go to do our lecture number 4 here. All right, have a nice day. Bye.